Hi everyone, welcome back to the channel. This question was asked in IIT JEE 2025 in advanced, and it seems that there are some more information missing here because there are too many variables. And how do we calculate the maximum angular deviation theta? I will solve it using classical mechanics, the linear momentum conservation here. And then the problem is simple enough, but in the end, you might need to think a little bit and apply some logical thinking. So let's start solving this problem. So let's assume that this angle is alpha. Let's say it's moving with velocity u, and after collision v1, and for n it is v2. Okay, that's it. We don't have much information here beyond this. Let's take this as x-axis and this one is y-axis. You will notice that the actual force in any direction, Fx, sum of all forces in x direction, and sum of all forces in y direction, they're 0. Okay, so we can conclude that linear momentum is conserved in both directions, in x and y, right? Point 1, linear momentum and energy, they are conserved. And what are the unknowns here? So we know that u we don't know, v1 we don't know, v2 we don't know, theta we don't know, alpha we don't know. So many unknowns. Okay, clearly think that there are only going to be 3 equations. Since fx is 0, so in x direction we write the linear momentum equation, which is 2mu should be equal to 2m v1 cos theta plus m v2 cos alpha. Okay, which means 2u equal to 2v1 cos theta plus v2 cos alpha. Let's call this 1. Okay, we also have fy 0, so which means 2m v1 sin theta equal to v m v2 sin alpha. Therefore 2v1 sin theta equal to v2 sin alpha. Let's call this 2. So from 1 and 2 we can get 2u minus 2v1 cos theta. We can write v2 1 minus sine square alpha. We're just rewriting this equation. Okay, and then we take square both the sides. v2 square 1 minus, now instead of sine alpha we'll put 2v1 by v2 sine theta. Square of this and this. Okay, now we can expand, so this will become 4u square plus 4v1 square cos square theta minus 8u v1 cos theta equal to v2 square 1 minus 4v1 square by v2 square sine square theta. Okay, and therefore we can write 4u square minus 8u v1 cos theta. We'll take this one the other side, so v2 square minus 4v1 square sine square theta and minus 4v1 square cos square theta. So this will simply become v2 square minus 4v1 square, and here we have 4u square minus 8u v1 cos theta. Okay, so let's just box this one and call it equation. Now we'll just go the next step on this side. so that we don't lose the sight of the equation. Okay. So we'll just have the energy conservation. So initial energy is half 2m u square if you see the diagram. Okay. Final energy is half 2m v1 square plus half m v2 square, which means it is just 2u square equal to 2v1 square plus v2 square. That means v2 square is nothing but 2u square minus 2v1 square. So what we are trying to do is, let's call it equation 4. What we are trying to do is getting rid of v2 in this one, in this third equation. So from 3 and 4, 4u square minus 8u v1 cos theta. Instead of v2 square, we'll write 2u square minus 2v1 square minus 4v1 square, which is equal to 2u square minus 6v1 square. So that means we can just write cos theta as 2u square plus 6v1 square divided by 8u v1, and which is nothing but u square plus 3v1 square by 4u v1. Now if you draw the diagram of cos theta, so cos theta starts with here and then it goes like this, right? This is 1 at 0 and this is pi by 2. So if theta increases, cos theta decreases. Let's say theta in 0 to pi by 2. Okay. As we keep increasing theta, at least cos theta decreases in this range. Okay. To maximize theta, we can minimize cos theta, right? So we need to minimize this. So we'll just differentiate it with respect to v1 because u is the initial velocity. So we just need to get rid of v1 here or find the v1 in terms of u so that we get d cos theta. So we'll take d cos theta, differentiate it with respect to v1, and that we get minus u by 4 v1 square plus 3 by 4 u, and if we put to 0, we get v1 square as u square by 3. That means v1 is u by root 3. Okay. Now, if we again differentiate this cos theta and dv1 square, then we'll just get u by 2v1 cube. And this is always positive because both u and v1 are positive. That means cos theta is minimum at v1 equal to u by root 3. Okay, so which means theta is max. Okay, now we put this in the cos theta, so cos theta becomes u square plus u square by 4 u square by root 3, right, which is 2 by 4 root 3 by 2. So that means theta is cos inverse root 3 by 2, which is pi by 6. And that's the answer. So answer here is D. I just used classical mechanics to solve this problem. And there are many other ways using which you can also solve the problem. And there are probably shortcuts also here. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT, JEE or other examinations. Keep up the great work.